Today, we're going to talk about a piece of technology that is honestly quietly changing our cities from the inside out. It's called smart glass, and it's here to solve a really fundamental problem with the buildings we spend almost all of our time in.
So let's just start with a number that is kind of staggering when you think about it. 90%. That's how much time the average person now spends indoors. 90% of our entire lives lived inside.
And that begs a pretty huge question, right? If we're inside that much, why are our buildings so often just not great? You know the feeling. It's too hot, it's too cold, or you've got that crazy glare that makes you pull the shades down, and suddenly you're sitting in the dark anyway.
This whole situation creates what you could call the window paradox, and it's a massive headache in modern architecture.
Here's the deal. We're basically wired to love windows. We need that natural light, we need to see the outside world. But from an engineering standpoint, a window is basically a giant energy leak. It's a hole in your otherwise insulated wall that lets heat pour in when it's hot and rush out when it's cold.
And look, this goes way beyond just being comfortable or saving a few bucks on the energy bill. The science on this is really clear now. Not getting enough good natural daylight actually messes with our bodies. It throws off our internal clocks, our circadian rhythms, and that's linked to a higher risk of, well, all sorts of things, from obesity to depression. So getting windows right isn't just a design choice, it's a public health issue.
For the folks who actually design our buildings, the architects and engineers, this whole paradox creates something they call the Green Building Challenge.
And this is the heart of the problem. They're constantly juggling three things that all fight with each other. They want low energy use, they want people inside to be comfortable, and they want to give us all plenty of daylight and those great views. But with old school materials, if you improve one, you almost always make one of the others worse. It's this endless, frustrating trade-off.
And plain old glass is the main culprit. It's static, it can't change. So you get blasted with heat, and the AC goes into overdrive. You get blinding glare, so what does everyone do? They pull down the blinds. And then you have to turn on all the electric lights, which uses a ton of energy and totally defeats the purpose of having a window in the first place. It's a vicious cycle. It's actually gotten so bad that some people are seriously arguing for making windows smaller again. But what if glass didn't have to be so static? What if it could actually be dynamic? What if it could be intelligent? Well, that is exactly where smart glass comes into the picture.
Now, the specific tech is called electrochromic glass, or EC glass for short. It's pretty amazing stuff. All it takes is a tiny bit of electricity to make the glass change its tint. And by doing that, you can control, with incredible precision, how much light and, this is the important part, how much heat gets through.
I absolutely love this analogy. It's the perfect way to get it. Think of EC glass as a controllable valve for heat and light. You can open it wide on a cool, sunny morning to let the warmth in, or you can crank it closed in the middle of a scorching afternoon to block the heat and glare. And the best part is, it's not some big, clunky thing bolted onto the window. It's this incredibly thin ceramic coating that's built right into a normal, insulated window. It's totally seamless. It just looks like a window.
Okay, so the idea is really slick, but does it actually work? Does it really solve that big trade-off problem we talked about? Let's look at the numbers, because this is where it gets really interesting.
This right here is it's mind-blowing. This is data from an energy model for a building in a super hot place like Phoenix. And it shows that a building with a massive amount of glass, like 50% of its walls or windows, but using smart glass, actually uses less total energy than a building with way smaller windows, just 30%, using normal glass. So you get more light, bigger views, and a lower energy bill. It's amazing. It also means architects get way more freedom. You know, a building's energy use is often super dependent on which way it's facing. But with smart glass, that energy penalty for not having the perfect orientation is way, way smaller. The glass basically adapts to the building, so the building doesn't have to be perfect.
All right, I know what some of you are probably thinking. The glass tints blue, right? So does that mean you feel like you're sitting in a giant fishbowl all day? It's a totally fair question.
And the answer is no, not at all. And the way they solve this is super clever. See, the clear windows let in so much more light, like 60 times more than the tinted ones. So you only need to leave a few windows clear, and the bright, neutral light from those panes completely floods the room and overpowers the tiny bit of blue light. To your eyes, the room just looks and feels totally natural.
And you can actually measure this. The quality of the light has what's called a color rendering index, or CRI, of 93. Now for comparison, a perfect score, direct sunlight, is 100. A 93 is considered excellent. It means colors look true and the light feels crisp and natural.
Okay, so we've seen the science, we've seen the data. Let's check out how this is all coming together out there in the real world. How are people using this to literally design the buildings of the future today?
So check out the Morgan Library at Colorado State. The architects had this vision for a beautiful all-glass cube. But think about it, in Colorado, with that high-altitude sun, a glass box would normally be a furnace, absolutely unbearable. Smart glass is what made the whole design possible. They get that stunning transparent look, but the space inside stays comfortable all day long.
Or let's flip to the total opposite environment, hot, sticky Miami. This bank has this huge 2-story wall of glass facing south and west. That's a recipe for disaster in Florida. But the smart glass is automated. It just tracks the sun throughout the day, tinting when it needs to, and blocking more than 90% of the solar heat. So it stays cool inside, and they get to keep that awesome modern open look.
And the tech just keeps getting better. The latest stuff has something called in-pane zoning. This means you can tint different parts of the same piece of glass separately. So you could tint the top half of the window to block the high sun, but leave the bottom half clear so you can still see out. How cool is that?
So let's circle all the way back to that first problem, that big challenge. Smart glass basically shatters the trade-offs. It proves that we can finally have it all. We can design buildings with incredible energy efficiency that are genuinely comfortable for us to be in, and that have the huge, beautiful, light-filled views that we're all drawn to.
So I'll just leave you with this one last thought. We've seen what a single smart building can do. But just scale that up for a second. Imagine the impact. What if every single window in your city could think? What if they could all react in real time to the sun, to the weather, to us? That's the future this technology is making possible.